What if we had a window into the brain so we could see what happens inside when we do things like thinking, planning, feeling, remembering? Meet Mini2P. Mini2P is a tiny brain explorer developed at the Kavli Institute for Systems Neuroscience at NTNU in Trondheim that allows us to discover completely new aspects of a living brain in action. This is Leif Eriksson the mouse with a window on his head. Here, he's equipped with the Mini2P. Inside Leif Eriksson's brain, a few brain cells burst with light. Soon after, other cells light up. A gene borrowed from jellyfish makes cells glow when they chat with each other. The bioluminescence lets the researchers see exactly which cells take part in different parts of the conversation. They can also watch how the neural conversation gives rise to ideas that the mouse then enacts in the outer world. The researchers can also color code the brain cells based on the role they play and the task they perform. This allows researchers to learn which types of brain cells must collaborate to generate different cognitive abilities. Mini2P can follow the mouse no matter what it does. That means it has to be extremely stable. Mini2P can follow the same brain cells with precision for more than a month, and it keeps these cells in focus even when the mouse is very active. Mini2P records simultaneously from thousands of brain cells. By using a kind of patchwork quilt technique, it can map even larger landscapes, like these 10,000 brain cells across the visual cortex. The microscope also covers the Z-axis and can record 3D volumes of brain tissue. Mini2P can explore different areas and mental functions all across the brain's cortex. The researchers have tested Mini2P in multiple areas of the brain, such as the navigation system, the memory hub, and the visual area. All these measurements were made while the mouse was moving freely and doing what it normally does. This was simply impossible before Mini2P. So let's pit Mini2P against the closest existing technologies. This is a benchtop 2-photon microscope. It weighs half a ton and takes up nearly the whole room. The benchtop microscope restricts the mouse's natural movement. That's nothing like a mouse would normally experience, which means its behavior probably isn't natural either. Mini2P, on the other hand, weighs 2.4 grams and allows the mouse to move just as freely and dynamically as it would without carrying a Mini2P on its head. The other technology is a 1-photon miniscope. And here we see a 1-photon miniscope recording from the brain area responsible for our sense of place and our navigational abilities. The recording is being made while the mouse is actively navigating. And here you see what the Mini2P records from the exact same cells in the exact same mouse engage in the same activity just a few minutes later. Hello, brain cells! We believe the Mini2P is a game changer, and we want to share it with neuroscientists and labs across the world. Mini2P is an open source invention available from the Kavli Institute for Systems Neuroscience at NTNU in Trondheim. Tool up your lab with the Mini2P Brain Explorer here. The future is here, and it will be evenly distributed.